equations, theorems. Next, circles, definition, equations, theorems. Next, parabola, definition, equations, theorems. Ellipse, definition. Next, equations of the ellipse, theorems. Next, hyperbola. Just a simple, fastly you can revise the total topic comprehensively. Very fastly you can revise the topics. That is the advantage. In algebra, permutations and combinations table, no doubt. Comparison important in mathematics. You will not do any mistakes. Now, see, in continuity, this is a small topic in calculus. So here, before going to this continuity, today I will remind you the knowledge of limits. Compulsory we require limits knowledge here. So in total calculus, we are going to deal with what type of functions now done. Functions. First, algebra functions. First note on algebra functions. In first PUC, already introduction is there for you. Here also, a clear discussion is there about functions. Functions, how to write these functions, how to read, and what is the domain, how to draw the graphs, practice perfectly. So in algebra functions, models are here noted on. The first one category is like polynomials, all polynomials, polynomial functions like x, x square, x cube. See the different polynomials. Polynomials, root x, 1 by root x, like this. Root x, 1 by root x, like this. Third one, square root of ax plus b, or 1 by square root of ax plus b. This type of models. And next, linear functions, ax plus b. Quadratic functions, ax square plus bx plus c. So like this, polynomial functions, all polynomial functions. Next, some special functions you discussed in first PUC. Mod x. Mod x, what is its domain? Mod x, domain and range and graph. Discussion is important. Greatest integer part of x. Greatest integer part of x. Already in first PUC you practiced it. What is domain, what is range, what is graph, important problems. Just remind that the textbook, that's all. Special one, fractional part of x. Just write the fractional part of the given number. Here integer part of x and just write the integer part of the given number. Whenever required, we'll discuss about all these. Next, sigmum of x. Sine of x, sigmum of x, sigmum function. Next, log x, logarithmic function. Next, a power x, like this. For example, like 2 power x, 3 power x, exponential functions. And e power x, special function, e power x. So these are the 12 important algebra functions, and by combining these one, you will get many functions, composite functions. We are going to use here algebra functions. Next, put the heading trigonometrical functions. We required trigonometrical functions also. Trigonometrical functions. Trigonometrical functions. Trigonometrical functions. Trigonometrical functions. Sin x, cos x, tan x, their reciprocal functions, cot x, secant x, and and cosecant x and cosecant x, trigonometrical functions. Just now we completed inverse trigonometrical functions, inverse trigonometrical functions, inverse trigonometrical functions. Sine inverse of x, sine inverse of x, cos inverse of x, tan inverse of x, cot inverse of x, secant inverse of x. Just now we completed this chapter. And cosecant inverse of x. So we are going to use these functions, and combining these by these functions you will get some composite functions. This year you have composite function definition also. Types of functions, composite functions discussion is there this year in second PUC, in first chapter it is. So practice how to read these functions, how to write these functions. You are learners in calculus. So writing, reading skills important. Very easy calculus. Very simple solutions in your PUC syllabus. If you go for higher classes, it is tough. But as per as PUC, very easy topic is calculus. Where you will face the difficulty and reading and writing skill. Practice reading and writing skill here. So before going to this continuity chapter, we discuss this one, limits. Not on properties of the limits. Properties of the limits. Just remind yourself, what are the properties of the limits? Properties of limits. Properties of limits. We discussed in first PUC. What is the first property here? Limit of x tends to a constant. How to write this limit? How to read? That is important for you. Limit of x tends to LT. I wrote simply LT. You can write full LMIT also. You can write. So this type of versions are there. This is one version. In some textbooks, they will write completely limit. In some textbooks, short form LT. Three types of categories are there: LT, limit, LT. But how to read this one? This is limit. Below that one, just below that one, write the limit. X tends to a constant. Always constant only. Limit of a constant. For example, limit x tends to a 7, you will get 7 only. 7 is a constant function. Limit x tends to a 10, answer is a 10. So limit of a constant, always constant. Second one, limit of x tends to a k into f of x. K into f of x. Limit, under that one write the x tends to a, parallelly write the function. K is a constant. We can write the constant outside. K into limit of x tends to a f of x. Simply at PUC level you have only properties. If you go higher level, proofs are there for all these things. By using the definition we can prove it. Next, algebra of the limits. Limit x tends to a sum of two functions, f of x plus g of x. Here we are writing only sum of two functions. For any number of functions, this property is same. If addition is there, you can apply the limit separately. Limit x tends to a f of x plus limit x tends to a g of x. As you are beginners in calculus, how am I reading, how I am writing, that is so important. Don't go in your own way. You will lose the marks simply. How we are writing, that is so important. How you are reading, both are important. Follow me, exactly follow me. Limit of x tends to a, f of x minus g of x. Limit x tends to a, f of x minus g of x. Limit of x tends to a, f of x minus limit x tends to a, g of x. In addition and subtraction, just I wrote only two for any number of functions. If addition is there, write the addition. If subtraction is there, write the subtraction. See the sixth one. Limit of x tends to a product f of x into g of x. Product of any number of functions, but practice for two functions. Limit x tends to a, limit x tends to a f of x into limit x tends to a g of x. Limit x tends to a f of x into g of x. When we have product of two functions, we can apply the limit separately. Limit x tends to a f of x into limit x tends to a g of x. When division is there, limit x tends to a f of x by g of x. Limit x tends to a f of x by g of x. So we can apply the limit for a numerator separately. Limit x tends to a f of x by limit x tends to a g of x, provided denominators are not equal to 0. In bracket note, provided g of x is not equal to 0, even limit x tends to a, g of x is also not equal to 0. Compulsory. Here, in this case, g of x not equal to 0. In this case, limit x tends to a, g of x is not equal to 0. In that case, we can apply this property. Otherwise, we have to go for alternative. Next one. Limit x tends to a, f of x whole power n. Limit x tends to a, f of x whole power n. Here, we can apply the limit for function. Limit x tends to a, f of x whole power n. Limit x tends to a, f of x whole power n. Ninth one. Limit x tends to a, f of x power g of x. Function power function. F of x power g of x. You can apply the limit for base separately, for power separately. So limit x tends to a, limit x tends to a, f of x power limit x tends to a, g of x. Mainly 9 properties. Practice these 9 properties. So how to practice these properties? Listen to me. First, note on left hand side, write the right side answers. Practice like this 2 times. If any mistake is there, practice that one. And note on right side, practice the left hand side. So left to right 5 times, right to left 5 times. Both you have to. Sometimes while solving the problems, we'll apply this formula left to right as well as right to left also. So both you have to practice. So write the 10 times for next day class. Practice this one 10 times. Next note on standard limits. Formula. Standard limits. Standard limits. Or in bracket formula. Standard limits. You completed. Yes, important theorem. First one. Limit of x tends to a, x power n minus a power n by x minus of a. What is the answer? n into a power n minus of 1. Second standard limit. Limit of theta tends to 0, sine theta by theta value, that is 1. Limit theta tends to 0, sine theta by theta is 1. Theta is measured in radians. Theta is measured in radians. Theta is measured in radians. In radians. Always keeping in your mind, calculus deals with real number system. Fundamentals. Calculus deals with real number system. Second one, in calculus, always the measurement of the angle is in radians. Always in which system? In radians system. What the formulas you are practicing, that is only for radians system. That is second important point. Third important point, logarithm base is always E. Logarithm base is always E. Write the third formula. Limit of theta tends to 0, tan theta by theta, that is 1. Limit theta tends to 0, tan theta by theta is 1. Next, fourth one. Limit x tends to 0, e power x minus of 1 by x. This is 1. In public exam, question is given for you based on this one last year. Limit x tends to 0, a power x minus of 1 by x, log a base e. Log a base e, base also important, log a base e. If substitution method is failed, when we can say it is failed? Note down indeterminate forms. Indeterminate forms. 0 by 0 mainly, infinity by infinity, 1 power infinity, infinity minus infinity. We should not use in mathematics 0 by 0, infinity by infinity, 1 power infinity, infinity minus infinity. So in substitution method, if you are getting real number, you can write the answer. Otherwise, if you are getting 0 by 0, infinity by infinity, 1 power infinity, infinity minus infinity, go for alternative methods. Go for alternative methods. Go for alternative methods. First method is rationalizing method. Rationalizing method. Based on the functions, we will rationalize the functions. Or factors method. Or factors method. Factors method. Factors method. Or else standard limits. We'll use the standard limits method. Standard limits method. Standard limits method. Standard limits. In PUC, you practice these four: substitution method, rationalizing method, factors method, and standard limits method. And one more, left limit and right limit method. Left limit and right limit. LHL and RHL method. Next, limit extends to infinity models. Limit extends to infinity. F of x models. So basically 6 models are there. If you go to KSET, another different methods are there. We'll discuss there. So properties, standard limits, and the methods of the limits. So practice the first PUC once again, textbook. And now done. Important note in limits. Limit extends to a, f of x is exist. Means that implies limit extends to a minus f of x is equal to limit extends to a plus f of x. Limit is exist means left limit must be equal to right limit. This is the fundamental. Actually, according to the definition, for every problem we have to find left limit and right limit. Both are exist means that is the limit value. This is the basic fundamental. But at your levels, we'll go with the direct limits only. Sometimes only we are following this left limit and right limit. So this is all first PUC knowledge. Now note on the definition of the continuity. Just listen to me. Before going to this continuity definition, see this example. F of x is equal to x square minus of 4 by x minus of 2. We'd like to find the f of 2 value. See the f of 2 value, 4 minus 4 by 2 minus of 2, 0 by 0. It is indeterminate form. So what we will do? If we draw the graph here, this is a f of x is equal to x plus 2, straight line you will get. The graph will be discontinued at x is equal to 2, exactly at x is equal to 2. The graph will be discontinued at x is equal to 2. So keep it in your mind this point. Now on the definition of the continuity. Definition of the continuity. Continuous function. What is a continuous function definition? Even we discussed this point in first PUC. To define the derivatives, it should be a continuous function. Once again, we'll define. A function, it should be a function first. A function is said to be continuous, at x is equal to a if limit value is equal to limit x tends to a, f of x is equal to f of a. This is the definition. Limit value must be equal to function value. Limit value must be equal to function value. A function f of x is said to be continuous at x is equal to a if limit extends to a, f of x is equal to f of a. This is the main definition. So limit extends to a, f of x is exist means we can write this formula. A function is continuous means that is not a. This is the clear condition. Limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to left limit is equal to right limit is equal to function value. This is the clear formula for continuity. To decide the continuity of any function, we have to find the left limit and the right limit and function value. If these three are equal, we can say the function is continuous. So we have problems based on to decide the continuity. What we have to prove? Left limit is equal to right limit is equal to function value. Or else if it is already given continuous, we can take this condition. Left limit is equal to right limit is equal to function value. Already continuous means. Or else to prove the continuity, you have two types of problems. Prove the continuity, what we have to prove? For given problem, left limit, right limit, and function value will decide. If all the three are equal, that function is continuous. Otherwise, if it is given already continuous, they will ask some conditions. That is important question for 4 marks. So, two types of problems you have. First model is prove the continuity. Second model is already they will give you the continuous function. We have to find the that some constants values. They will include some constants in functions. So already given continuous means what is the formula? It is always left limit is equal to, right limit is equal to, that is function value. That's all. Simple formula. 4 marks you will get. And some fundamentals we will discuss, not a note. First point. Every function is continuous in its domain. Every function is continuous in its domain. Every function is continuous in its domain. So we'll discuss with examples. Every function is continuous in its domain. Directly we can use while solving the problems. If you know the domain, we can write it is continuous in its domain. See the examples. Some examples we'll discuss. For example, I am taking important one. F of x is equal to mod x. See that if we draw the graph mod x, how you will get mod x graph? Is there any discontinuous point here? Mod x, f of x is equal to mod x. Its domain is R. What is its range? Mod x, closed interval, 0 to infinity. Domain and range. Mod x, domain and range. And mod x definition is, see this one. Mod x is equal to x. If x greater than 0, not on. Minus of x. If x less than 0 is equal to 0. If x is equal to 0. We required. You have number of problems based on this mod x. That's why I'm choosing this example. F of x is equal to mod x. Its domain is R. For every x belongs to, it is defined 0 to infinity. And mod x definition is x if x greater than 0 is equal to minus of x if x less than 0, equal to 0 if x is equal to 0. In first PUC we discussed this one. Draw the graph. Now tell me, is there any discontinuous points in graph? No discontinuous. So it is continuous on R. Note on that. Mod x is continuous on R. Mod x is continuous on R. Mod x is continuous on R. See another important example too. F of x is equal to step x, integer part of x. What is its domain? Its domain. F of x is equal to step x. Its domain is, it is defined for every real number. What is its range? Integers, that's all. Z, R to Z. But this function is not continuous in its domain. Exceptional case, one exceptional case. See this one. If we draw the graph, see the 0 to 1, we'll get 0 only. 1 to 2, you'll get 1 graph. 2 to 3, we'll get the value 2 only. 3 to 4, when the value is in between 3 to 4, we'll get 3 only. See, steps, and these steps are discontinuous. See, where it is discontinuous? At integral values. So step x is discontinuous at integer values of x and continuous at non-integral values. Non-integral ante 1.1, 1.2, 1.3 like this, 2.1, 2.2, 3.4, all non-integral values. Note an important point. Not an fx. First define the function. It is defined for all x belongs to R. Domain is R. Range is integers. Not done. Step x is step x first point. Step x is discontinuous. Step x is discontinuous at integral values of x or integer values of x. Both are same. Integral values. Don't get confusion. Integer values. Step x is discontinuous at integer values of x and is continuous second point. Step x is continuous at non-integer values of x. At non-integer values of x. So these two, why I can have many problems based on these two, mod x and step x. Next, another example I'm taking. See the example 3. I'm taking f of x is equal to sin x. What is sin x graph? What is its domain and what is its range? Domain or range is closed interval -1 to 1. See its graph 0 to pi, pi to 2 pi. Like this it will goes. It is continuous on R. So note down. Sin x is continuous on R. Is continuous on R. So except this case, almost all, every function is continuous on its domain. And one more important example, note down. Example 4. Any polynomial function, any polynomial function is continuous on R. Any polynomial function, either linear, quadratic, biquadratic, whatever it may be. Any polynomial function is continuous on R. Next point. Constant function is continuous on R. Constant function is continuous on R. Constant function is continuous on R. So while solving the problems, we'll follow these examples and properties. Note down second point. Point number 2. Let f of x is continuous at x is equal to a, and g of x is continuous at x is equal to a. Let f of x is continuous at x is equal to a, and g of x is also continuous at x is equal to a. Here note on the points. Then first point, sum of these two functions, f of x plus g of x is continuous at x is equal to a. F of x plus g of x is continuous at x is equal to a. Second one, f of x minus g of x, f of x minus g of x is continuous at x is equal to a, is continuous at x is equal to a. Third one, f of x into g of x is continuous at x is equal to a. Even f of x by g of x is continuous at x is equal to a. At x is equal to a. Here in bracket note down, g of x is not equal to 0. Denominator should not be 0. F of x by g of x. So see that if f of x is continuous at a particular point x is equal to a, g of x is also continuous at x is equal to a. Sum of these two functions is also continuous at x is equal to a. Subtraction of these two, f of x minus g of x is also continuous at x is equal to a. F of x into g of x is also continuous at x is equal to a. F of x by g of x is also continuous at x is equal to a. So we'll use this property. Third one order. See, let f and g are, let f or f of x and g of x are real valued functions. Are real valued functions. What is the meaning of real valued functions? Their domain must be real numbers or subset of real numbers. Real valued functions means. And g of x is continuous at x is equal to c, and f of x is continuous at x is equal to g of c. See this one. G of x is continuous at x is equal to c, and f of x is continuous at x is equal to g of c. Then f circle g of c, f circle g of x is continuous at x is equal to c. This is composite function. F circle g of x, f of g of x. F circle g of x means note on that one. The meaning of this one is f of g of x, composite function. This here discussion is there. In functions it is there, in derivatives it is there. Composite function. What is a composite function? See, I'm taking one example here to define this property. Let f of x is equal to cos x, and g of x is equal to mod x. G of x is equal to mod x. Cos x is continuous on R, mod x is continuous on R. So no problem, this is good. See this one. Then I am defining f circle g of x as cos of mod x. Cos of mod x. Cos of mod x, f circle g of x, f of g of x. So this is not cos x, cos of mod x, combination of two functions, cos of log x, cos of root x, cos of sin x, combination of two, not only two, any number of combinations we can prepare composite functions. Two or more, composite function is combined by two or more functions. It is called composite function. So cos of mod x. Now listen to me. Mod x is continuous on R. Cos x is continuous on R. So cos of mod x is continuous on R. Note on that. Here mod x is continuous on R. Here mod x is continuous. Mod x is continuous on R, and cos x is continuous on R. So cos of mod x is continuous on R. Cos of mod x is continuous on R. So to solve the next exercise, the knowledge which is required for you is, first one is continuity definition. What is continuity definition? Left limit is equal to right limit is equal to function value. Next, if f of x is continuous at x is equal to a, g of x is continuous at x is equal to a, then we can write f of x plus g of x is continuous at x is equal to a, f of x minus g of x, f of x into g of x, f of x by g of x. Keeping in your mind, second point. Third one, this one. Start that exercise. Okay, tomorrow we'll discuss the problems. All of you practice the properties of the limits and the methods of the limits, and three fundamentals were discussed in continuity. Practice these things. Tomorrow I'm going to give the question paper for you, inverse trigonometrical functions. After 12 o'clock, I will keep that one in WhatsApp for you. But what is your responsibility? Preparing thoroughly, then write that exam and do the self-correction yourself. Thank you.